This guy's name is Frank Drake. And he was into studying what are the odds of finding extraterrestrial intelligence in our galaxy. And he actually did some math to figure out what the odds of that are. What are the odds that there is something like us, really smart things, aliens somewhere, that are on a planet kind of like Earth, maybe, that are looking around in space with telescopes, sending out messages? What are the odds of that? So that has been scientifically studied, and this guy founded the study of that, and he came up with the Drake equation. So here's the Drake equation. N equals N star times F sub P, we're going to talk about what each of these things is, times N sub E times F sub L times F sub I times F sub C times F sub L. And he said if you multiply all this together, you get N, which is the number of technological radio telescope signal producing species in our galaxy. So let's go through this whole equation. N is the number of planets out there like us, in other words. Is there more than one? Well, the first thing you got to do is you got to plug in the number of stars in our galaxy. How many stars are there in our galaxy? Does anyone remember? 200 billion. Oh, y'all just read it. 200 billion. That's the first number. And that's what you start with, and that's what you're gonna take this number and you're gonna multiply it by all these. F means fractions. F are fractions and N are numbers. So you multiply it by fractions and numbers to end up with the total number of planets like ours in our galaxy. So the first thing we got to do, because planets go around stars, so the first thing we got to do is figure out the number of stars. There's about 200 billion stars in our galaxy. We're pretty confident of that. You can see them with telescopes, and you can count them, and we know how big our galaxy is, and you can do some math and figure out how many stars are in our galaxy. Does that make sense? Amy, you with me? That's the plane of the Milky Way galaxy. Remember that? We went out to the beach and saw that. We went out to the beach.
And is the total number or the total number in our galaxy?
The number in our galaxy.
But no, I mean like...
Yes.
Yeah.
This is the total number of advanced civilizations in our galaxy.
In our galaxy, but not the universe.
In our galaxy.
Wow, okay.
Okay?
Got it.
We figure if they're in other galaxies, how would we ever get to them? I mean, they're just so far away. They're so far away in our galaxy, but let's just worry about our galaxy for now.
Right, got it.
Right, Sam?
Yeah, right.
You gonna travel that far sometime?
I hope so.
Oh, me too. That's a great answer. Then you multiply by F. F is a fraction. The fraction, F sub P, is the fraction of stars that have planets around them. So if it's just a star, it's not going to help us. So we're going to multiply by the fraction that actually have planets. We want planets that are going around stars like Earth is. So what is that fraction? Well, we know from looking through our telescopes and able to measure the wobble of stars and such that planets produce. We know from looking at all these other stars that almost every star has planets around it. So that fraction is very close to 1. Almost every star has planets around it. But when we're doing these calculations, we're going to be a little bit, it's probably not all of them. You know, there's probably some that don't have planets, and we haven't seen everything. We've only able to measure the stars that are close to us. So we're just going to say it's not 1, it's 0.7. We're being conservative in our estimates. Okay? So 70% of the stars we'll guess have planets around them. Although right now it's a lot closer to 100%, but we haven't seen all the stars, and there's probably some without planets. Then you got to multiply by n sub e. That's the number of planets per star that are ecologically suitable for life. So how many planets are there going around the stars, around each star, where life can be on that planet? Well, around the sun, there's one that's very suitable for life. That's ours. And there are 2 others that are almost suitable for life. Venus is just a little too close to the sun, and that caused a runaway greenhouse effect, which ended up making it too hot. And Mars is just a little bit too far from the sun, and that caused it to be a little too cold. So we're right in the middle of this zone that's perfect. It's called the Goldilocks Zone. Not too hot and not too cold. That's the real name for it. And they show the Goldilocks Zone is here in green in these pictures. So here's a blue star, kind of a hot star. There's its Goldilocks Zone, the green zone. Here's a yellow star like us. There's its Goldilocks Zone. And we're this middle circle here. There's Earth right in the middle of the Goldilocks Zone. And then here's a smaller red star, and you can see it has a smaller Goldilocks Zone. If our sun were a red star, Venus would be right in the middle of the Goldilocks Zone. Yes?
Does Mars kind of hug the Goldilocks Zone?
Mars is just outside of it. See, here's the green is the Goldilocks Zone, and there's Mars' orbit right there. Just outside of it. But if our star were a blue star, Mars would be right in the middle of the Goldilocks Zone. Yeah?
So every star has this Goldilocks zone?
Every star has a Goldilocks Zone. And that's the distance that's not too close where it gets hot, and it's not too far where it's too cold. It's the just right distance. And when we say too hot and too cold, we're talking about water, really. We're talking about hot enough to keep water in liquid form on the planet. If it's too close, it'll become gaseous and leave the planet, or just be this hot gas floating around in the air. And if it's too hot, it'll be that way. And if it's too cold, it'll freeze. So you want the area where water stays in liquid form, because we kind of associate life with water on our planet. So we're going to say, since our star has 1 planet in the Goldilocks Zone, but very close to 3, but just 1, we're going to assume that for stars that do have planets, that there's an average of 1 planet in the Goldilocks Zone. Now, this number, scientists have said, could be way higher if it's true that there's life on places like Europa under the ice, or if there's life, in some other form that we don't understand. But even if life did evolve on Europa under the ice, we don't know if it could it get intelligent, where it has radio communication and that sort of stuff under that ice. It's hard to imagine. Let's just call it 1 for now. That's somewhat conservative. Then we multiply by F sub L, the fraction of planets suitable for life that life actually evolves. So we're giving that 0.5. We're saying if it's a planet in the Goldilocks Zone, what are the odds that life actually comes about on it? Now, a lot of scientists think that this number is probably a lot higher than 0.5. Maybe it's around 1. Because life came about on our planet real fast. our planet formed 4.6 billion years ago, and we know there was life about 4 billion years ago. We have fossilized evidence. That's in roughly 10% of the history of the world. In a short time, life evolved. So maybe that's what happens normally on any planet in the Goldilocks Zone. Maybe life will come about somewhat quickly, but maybe not. We don't really know because Earth is our only example. So let's once again be conservative and not put it around 1. Let's just say it happens on half the planets, 0.5. On half the planets in the Goldilocks Zone, life evolves. Now, there may be something about our planet that's totally different than other planets around other stars. We can't see them yet. That allowed us to evolve life, but not around those stars. It wouldn't happen. So this number could be way lower, but maybe it's higher. Who knows? Let's just call it 0.5. The fraction of planets with life that evolve intelligence. So, you have to understand biology a little bit to understand what intelligence is. But to get smart creatures like humans, you have to get complexity. And a lot of scientists say, well, over time, organisms get more and more complex. That's natural selection. It selects for more complicated, smarter beings. And over the 4 billion year history of our planet, organisms got more and more complex and more intelligent. And so a lot of scientists say that's the natural order of things. You will eventually reach an intelligent organism. And if that's true, that you'll eventually evolve to have an intelligent organism, then F sub I would be 1. But if it's not true, where you don't eventually evolve to have an intelligent organism, then that number is going to be a lot lower. And it did take 4 billion years to evolve something as smart as us. So, let's be conservative again and just say F sub I, where an intelligent organism evolves, is only 1/10. Only a tenth of the planets evolve an intelligent organism. Some scientists say, nah, it's much lower than that. It's hard to know since we only have our planet as an example. Y'all know who that is, by the way?
Albert Einstein.
That's it. That's Einstein as a young man. Good looking guy, wasn't he? Smartest guy in the world. Isn't that pretty cool? Who's the smartest guy in the world? This guy. Hey, yeah, it is me. Then you got to multiply by F sub C. The fraction of planets with intelligent life that develop civilizations with radio communication. Radio telescopes can send messages a long way and can receive messages from a long way. And that's probably what we're going to interact with first. A radio message from one of these intelligent life forms. Probably won't be visited by them like it's in all the movies. It's just too far to travel. Radio waves can travel at the speed of light, whereas a spaceship has to travel much slower. So we'll probably get radio communication from these aliens first. So what are the odds that if you have intelligent life that you'll develop radio communication? That's kind of a guess. We don't know. You want to say 10%? 1 out of 10? What are the odds that your intelligent organisms are so smart that they come up with radio communication? I mean, apes couldn't come up with that, but they're really smart. Dogs couldn't come up with that. Your dog's pretty intelligent. Dolphins are really intelligent, but they probably couldn't come up with radio telescopes. That would be cool if they could. So maybe only 1/10 of the time do you get something that's intelligent and can also come up with radio telescopes. We were able to do it probably because our opposable thumbs that allowed us to make tools. You don't see dolphins making a lot of tools. They just don't have the thumbs for it. F sub L, the fraction of the planet's history that technological civilizations exist. Okay, so we're a technological civilization that can produce radio telescopes. How long have we been able to do that? How long have radio telescopes been around?
Not very long.
50 years.
Let's round it to make it easy math. 100 years. And it is probably closer to 100 years ago we had the first radio telescope. 100 years out of 4.6 billion. That's a pretty small fraction. It's like I have it written in the book, 0.0000002 or something like that. If our civilization were to die out tomorrow, that's what fraction you'd have to multiply by, 0.00002. But if our civilization lives on and on for thousands, millions, billions of years with this technology, then that fraction gets a lot smaller. For instance, let's say our civilization lives out for another 4.6 billion years until our sun goes out or expands and swallows up the Earth. Well, then that fraction is 0.5 because half the history of the Earth has intelligent radio signal producing organisms. So probably our maximum could be 0.5, but our minimum is 0.00002. So what do we want to settle on? Scientists have come up with a number that's probably conservative, 0.0001. That's the average fraction of a planet's time that is filled with a technological civilization. 1/10,000th of the history of the planet has the technological radio producing civilization. So let's take all these numbers and add them up. And you end up with 35,000.
Why does that say 100 billion?
Oh, I don't know.
So something's off.
Let's change this to 100 billion. There's different numbers scientists have plugged in for this. I think that number takes into account that a lot of the stars are dwarf stars that might not be able to have much chance of life. And a lot of stars, there's also a Goldilocks zone in our galaxy. That's more what that's taking in. We think that if the stars are in the very center of the galaxy, the galactic bulge, there might be too much energy in there for living things to evolve.
So you want us to use 100 billion?
Yeah, so let's use 100 billion for this calculation. If you use 100 billion there, you end up with 35,000. 35,000 intelligent civilizations with radio broadcasting in our galaxy. There should be 35,000 like us out there, if our numbers are right. 35,000. So, why haven't we heard from them? Where are they? That's the next question we'll talk about. Let's see Carl. Whoops. Why did I do that? Freaking out here. I meant to turn it off, and it was already off. Craziness. Let's see video footage of Carl Sagan working out this equation.
Carl Sagan.
Did I mention he's my favorite scientist?
Fios is not cable. We're wired differently. That means incredibly fast 150 meg internet for the holidays. So in the 3.7 seconds it takes Gary Watson to beat the local sled jump record, his friend can download 13 versions of a perfect song. His sister can live stream it, while his mom downloads how to set a dislocated shoulder. Get 150 meg internet, TV, and phone for just $79.99 per month online for the first year. Cable can't offer that. Only Fios can.
Great commercial.
There are an enormous number of stars. Only some of them will have planets suitable for life. On only some of those worlds will intelligence arise. And perhaps a few of those civilizations will avoid the trap jointly set by their technology and their passions. If there are many civilizations, one of them should be rather close by. If there are few civilizations, then even the nearest may be very far away. This is one of the great questions. How many advanced civilizations capable, at least of radio astronomy, are there in the Milky Way galaxy? Let's call the number of such civilizations by the capital letter N. It's a number. It depends on many things. It depends on the total number of stars in the Milky Way. Let's call that N sub star. It depends on the fraction of stars that have planets. Let's call that F sub P. It depends on the average number of planets in a given solar system that are ecologically suitable for life. Let's call that N sub E. It depends on the fraction of suitable planets in which life actually arises. Call that F sub L. It depends on the fraction of inhabited planets on which intelligence emerges. Let's call that F sub I. And on the fraction of those planets in which the intelligent beings evolve a technical communicative civilization. Call that F sub C. Finally, it depends on the fraction of a planet's lifetime that's graced by a technical civilization. Call that F sub L. If we multiply all these numbers together, we've estimated capital N, the number of civilizations. This equation, due mainly to Frank Drake of Cornell, is only a sentence. The verb is equals. So let's try to go through the program of this equation. By carefully counting the number of stars in small but representative regions of the sky, we find that the total number of stars in the Milky Way is about 400 billion. It's a lot of stars. What about planets? Well, in studies of double stars and investigations of the motions of nearby stars, and in many theoretical studies, we get a strong hint that many, perhaps even most stars, are accompanied by planets. So let's take F sub P, the fraction of stars that have planets, as a quarter. Then the total number of planetary systems in the galaxy is 400 billion times a quarter, or 100 billion. We'll write down our running totals in red. Now, each system were to have, say, 10 planets, as ours does, there would be 100 billion times 10, or 1 trillion worlds in the galaxy, a vast arena for the cosmic drama. In our own solar system, there are several bodies that might be suitable for life of some sort. There's the Earth, of course, but there are possibilities for Mars, for Titan, perhaps for Jupiter. If other systems are similar, there may be many suitable worlds per system, but to be conservative, let's choose N sub E equal 2. 2 worlds suitable for life per system. Then the number of planets in the galaxy that are suitable for life would be 100 billion times 2, or 200 billion. Now what about life? Under very general cosmic conditions, the molecules of life are readily made. They spontaneously self-assemble. It's conceivable there might be some impediment, like some difficulty in the origin of the genetic code, say, although I think that's very unlikely given billions of years of evolution. On the Earth, life arose very fast after the planet was formed. So let's choose F sub L, the fraction of suitable worlds in which life does arise, as a half. In that case, the total number of planets in the Milky Way in which life has arisen once is 100 billion times 2 times a half, or again, 100 billion. 100 billion inhabited worlds. Now, the estimates get tougher. Many individually unlikely events have to occur for our species and our technology to emerge. On the other hand, there might be many different roads to high technology. Some scientists think that the path from trilobites to radio telescopes, or the equivalent, goes like a shot in all planetary systems. Other scientists disagree. Let's take some middle ground and choose F sub I as a tenth, and F sub C is also a tenth, meaning that only 1%, a tenth times a tenth, of inhabited planets eventually produce a technical civilization. If we were to multiply all these factors together, we would find 100 billion times a tenth times a tenth or 1 billion planets on which civilizations have arisen at least once. Now, what percentage of the lifetime of a planet is marked by a technical civilization? The Earth has harbored a civilization capable of radio astronomy only for a few decades, the last few decades, of a lifetime of a few billion years. It's hardly out of the question that we might destroy ourselves tomorrow. If that's a typical case, then F sub big L would be a few decades divided by a few billion years, or 100 millionth, a very small number, and then big N would be a billion times 100 millionth, or in maybe just 10 civilizations, a tiny smattering of pitiful few technological civilizations in the galaxy. But civilizations then might take billions of years of tortuous evolution to arise and then snuff themselves out in an instant of unforgivable neglect. If this is a typical case, there may be few others, maybe nobody else at all for us to talk to. But consider the alternative, that occasionally civilizations learn to live with high technology and survive for geological or stellar evolutionary timescales. If only 1% of civilizations can survive technological adolescence, then F sub big L would be not 100 millionth, but only 100th. And then the number of civilizations would be 1 billion times 100. The number of civilizations in the galaxy then would be measured in the millions. Millions of technical civilizations.
So, if civilizations do not always destroy themselves shortly after discovering radio astronomy, then the sky may be softly humming with messages from the stars, with signals from civilizations enormously older and wiser than we.
Yeah, got a lot of guys used to imitate Carl Sagan with that voice that he's got billions and billions. He's kind of famous for that. So, if there are other radio-producing civilizations out there, are we looking for them? The answer is yes. There's a group called SETI, which stands for the Search for Extraterrestrial Intelligence.
That was in the movie.
It was in the movie, Contact, which you can check out and look at. It's a great movie. It has Matthew McConaughey in it, ladies.
I love him.
But anyway, the SETI is this group. They rent radio. It's a private organization. It's not government run. They rent. They raise money from donations. They rent these radio telescopes and they shine them around the sky looking for alien radio signals. But it's done very scientifically. They make sure to cover each point in space. They have these computer programs that will search through any signals to see if they're signals that are likely to be produced by aliens. For instance, what would our signals be like leaking from the Earth? What would they sound like to another civilization with these computers? Music that comes from our radio stations and TV signals and speech has certain things in it that are unlike any other thing that would be coming from space. So you have to search for signals like that. And where would we search? We would likely search in what's called the water hole. If you're an intelligent civilization that has science, you know that there's a part of the radio spectrum called the water hole. And it's near the vibrations of hydrogen and hydroxide. This is why they call it the water hole. Because hydrogen and hydroxide vibrate naturally at a certain frequency. This is frequency down here. Hydrogen and hydroxide vibrate at a certain frequency, and at that frequency, around where they vibrate, there's not a whole lot of static. There's not a whole lot of other vibrations. You can see over here there's a lot of static, a lot of energy. This is the amount of energy on this axis. A lot of energy and static produced by a lot of other molecules. But there's an area between 1 and 10 gigahertz vibrations. Do y'all know what a hertz is? Hertz is vibrations per second. So gigahertz is billion vibrations per second. But in between 1 and 10 billion vibrations per second, there's not a lot of static in space. That's the best area for sending radio signals and receiving signals. It's like, y'all don't have to tune radios anymore, but when I was a kid, you would turn your radio dial and you were listening to AM, and there's a lot of static, and then there'd be areas that were quiet, where you could hear the radio signal coming in and listen to the radio. Those are the old days. Y'all are spoiled with your satellite radio and stuff like that. Have we sent messages to other civilizations? Yes. This is called the Arecibo message. It was sent from the giant Arecibo telescope. Remember that telescope that's in the mountains down in South America? It's the biggest telescope in the world. We fed a message in. This is the message we sent. And this message has coded stuff in it. And you can look it up, the Arecibo message, onto what this message says. But it has code in it that should be able to be deconstructed and read by an intelligent civilization. To test that, they took this code and they gave it to a bunch of scientists who had never seen the code before, and asked the scientists if they could deconstruct it and make sense out of it. And the scientists sat down with it for a few days and figured out what it meant. And so we think that aliens, if they were as smart as us, could probably do that if they received this message. And the message was then sent out of that Arecibo telescope to a far off star cluster. It won't get there for 20,000 years, but because it has to travel at the speed of light. So 20,000 years from now, if there are alien civilizations in that star cluster, they will get our message, and they'll say, "Oh," if they are looking around like we are with radio telescopes. And perhaps that's why we haven't yet received a message. The message haven't gotten to us yet from these other places. Because light, even as fast as light travels, it takes a long time to travel through the galaxy. So, you never know. We might make contact with alien civilizations in the future, and that's what that movie's about. Yeah.
Can the spacecraft, like the Messenger and all those, receive radio waves?
Well, yes, but they're usually just pointed at us. You have to have your dish pointed in the right direction. So those dishes are pointed at us to get signals from the Earth. Okay. So they're not going to receive any. Excuse me. We have put plaques on all of those spacecraft that have left our solar system. And Messenger, by the way, never left our solar system. It's going around Mercury. But there have been some, Pioneer and Voyager, that have left our solar system, and they're all carrying these plaques, which we talked about this plaque earlier, didn't we? Mm-hmm. It has a coded message where aliens, if they ever did find the spacecraft, could figure out what the plaque says and where we are and who sent it and that sort of thing. This is a coded message. These plaques are on those things. They also carry a CD or like a DVD with information about tons of coded information about our planet. And they're on those spacecraft, and out in deep space, they ought to last millions of years because there's nothing to mess them up. There's no atoms or anything out there to screw up the record or the plaque. So 1 billion years from now, those plaques might be found by alien civilizations. And even if we've been eliminated, at least they knew we were here.
Oh my gosh.
That's it. That's the end of the class.